Welcome to chapter 10. This is the third mini lecture for this chapter. So let's jump in right where we left off, talking about precipitation. So four major patterns that we look at for precipitation. We have a humid, semi-humid, semi-arid, and then an arid region. So on this PowerPoint, you can see the different rainfall in inches. So humid, there's going to be anywhere from 40 inches or on of rainfall. Semi-humid, anywhere from 30 to 40 inches of rainfall per year. Semi-arid, 10 to 20 inches of rainfall per year, and then arid regions, anything 10 or less of rainfall. So when you're looking at this in terms of the United States, there's a lot more ways that this can be broken down. And so if you were to look at southern or Texas, that actually has four different indexes of rainfall. So it can get a lot of rainfall in some areas, especially in the eastern part of Texas, but not a lot in the western part of Texas. So different ranges for different parts of the United States. And that's kind of a kicker in terms of the way the USDA looks at rainfall, because if there's too much or too little of rain, so if we're either in a drought or a flood, the USDA might say there's a need for assistance for the western part of the Texas, but the eastern part of Texas might not get that. So precipitation patterns are different in all varieties of the world, but especially in the United States. So now let's look at the difference between drought and flood. We obviously know that a drought is just not any water. So why is that important to really know and to be cautious of? There's this thing called the Palmer Drought Severity Index, and it shows us about 100 years of the drought weather that we've had. And if you look back 100 years ago, even to like 1895 or 1896, we can see that we have had drought many times within those last 100 years. And so the Palmer Drought Index just shows us that pattern as to where that deficiency in normal precipitation is happening, and especially if it's prolonged. So like the drought of 2012 to 2015, a little bit into 2011 into 2015, that's going to show on that Palmer Drought Index. And so 100 years from now, farmers and ranchers are going to be able to see that as well. What's the big part of it? It's going to be very expensive to damage crops. It's going to really hurt the pocketbook of agriculturalists, and that's really, really tough in those years, because you plant that seed hoping to make a product or hoping to make a profit, and you might actually have to end up baling that corn, like a corn plant, for feed for any like livestock, like cattle. This shouldn't be confused with semi-arid or arid climates, because they naturally have low rainfall. So we know that Arizona is going to have a lot less rainfall than the eastern part, like an eastern state like North or South Carolina. We know that. So their index is going to be a lot different than each other. So on average, a drought costs the United States, specifically the USDA, about $6 to $8 billion. Okay, so that's not only the USDA, but also the consumer that's consuming the food. The food costs might go up a little bit more. It's going to take a little bit more to get it out of the field. So that's going to cost the United States about $6 to $8 billion on an average year. So this is a picture of obviously a drought-stressed crop plant, and you can definitely see some, chlorophyll is not happening, so photosynthesis is not happening, so we're seeing very dry, brown leaves. Same with the soil. It's very dry. There's no moisture in it. And that corn plant is definitely not going to be able to survive because it shouldn't be tasseling like it's starting to already tassel at 4 foot tall right there. It's actually going to start to tassel, and then will mature and not produce any type of kernel. Okay? So next, let's talk about flood. Obviously, we have too much water, so we either have too less or too much water. Very, very vital to the success of that crop. If we have too much water, it will become flooded and will not be able to bring back that crop if it's on there too long. because it's not able to survive in that water-like substance, those flooding conditions tend to be a little bit more observed when you're just driving down the road. You can definitely see a flooding impact rather than a drought impact. Drought impacts we tend to see more on a yearly basis. Flooding impact is more like a weekly basis. If we get 7 inches of rain in a period of 4 hours, we're going to be seeing that in its intensity for the next week or 2 weeks, depending on how long it takes to either drain off or go percolate into the soil. So this is a young corn plant. This is from Purdue University, but this is it looks like a pond on corn plants, which is not good, especially in this stage of development that corn plant is in. So not going to probably recover from that. And it's not good because that means that farmer is going to have to replant, spend some more money on seed, go to his or her crop insurance guy and say, hey, I need to replant. And so they're going to have to mess with that insurance a little bit more. Then FSA is going to have to get involved, and not a very fun time for farmers and ranchers in the spring, because this unfortunately happens more often than not. So temperature. We've talked about the intensity of temperature and why it's important for the earth to not get higher temperature like we've had in the past 100 years. But what does that mean for plant growth? So in the United States, we measure it in a Fahrenheit scale. Many other countries, except for us, I think it's us and 4 other countries, measure it in Fahrenheit. Everyone else is on a Celsius scale. And how do we see that? It's influenced by the altitude, the latitude, and how much water is given at any given time. So this is a picture of a corn plant that is temperature stressed. So we look at this, when we see this, the first thing that should come into that producer's mind is it's very stressed. So we can see that plant is reaching for water, not reaching for sun, but reaching for water. And you can see that because of the brown leaves there on the plant as well, which is not a fun sight to see because, again, it's not photosynthesizing because chlorophyll is not interacting with that plant and will not produce an ear of corn, and you can already see it tasseling up there as well, which is not good. So season and latitude effects, we're going to really look into this week in class, but we have a big variation from obviously the northern to the southern latitudes. We're able to grow crops on the southern part of the United States anywhere from 300 days on, whether that be grass, whatever. But in northern latitudes, about 70 days is where that growth period starts. So folks in Alaska really have a shorter period to grow different crop plants. But down here, we can plant anywhere from 100 to 300 days, depending on what that plant entails. So how does the temperature affect the plant process? Again, we talked about stressing and how different plants will stress different ways, but what kind of stressing happens because of the temperature? So we have like freeze injury, we have chilling injury, and we have heat injury. So that picture that I showed you 2 slides ago was definitely a heat injury because there was too high of a temperature, and that's going to really affect a lot of the photosynthesis that's happening in there. But on the other spectrum of that, we also see freeze injury, which this spring of 2018, a lot of us saw freeze injury in corn, and we'll talk about that in just a second. Okay, so this is a table that I want you to kind of look through. So you have the different plant type, what it is, and then the minimum, optimum, and then maximum temperature. So let's just look at corn real quick. So very tropical plant, very warm season plant. The minimum temperature that should be planted is 50 degrees. Okay, 50 degrees. The optimum temperature that it should be growing in is 86 to 95. So when it's within that growth and development stage, anywhere from 86 to 95. Maximum, when it's really going to start to hurt that plant, is 113. And that could be within days. And, living in Oklahoma, our temperatures get very close to 100, if not above 100, especially in the summertime. So we can definitely see that that stress a little bit more in the summertime. But if you think about the minimum, okay, so think about spring of 2018, we had some random freezes in the whole month of March. I think we had 3 right after spring break where it got below 32 for more than 8 hours a day at that time. And so a lot of folks around this area planted corn during our spring break, which is either the second or third week of March, and unfortunately had to replant because that temperature had dipped down to 32 degrees for more than 6 to 8 hours, which really hurt that corn plant. It was already above out of the ground. It wasn't in that warm climate in the ground. So it really hurt the growth, and many people unfortunately had to replant. In some cases it might be 100 acres, in some cases it might be 5,000 acres. And so that really takes a toll on that producer because of that temperature growth. But that's just another reason to be very vigilant and to know, kind of plan towards how cold or hot that weather or climate might be. So just like we talked about freezing injury, chilling injury, it's going to be above freezing temperatures, but it might still have some sort of effect, and then heat injury. So how do we manage this? How does somebody that has just planted 5,000 acres of corn all of a sudden have to then figure out how he's going to replant those 5,000 acres of corn because of freeze injury in southern Kansas? Well, the cool thing that we can do as producers and as scientists is pick crop species and varieties that will adapt to that location, which is so vital for agriculture. So we have to make sure that if I know, or I think, or I have this feeling my right toe is hurting in March, that it's going to be a hot winter, or hot summer, excuse me, then I'm going to try and pick a variety of corn that will withstand that hot climate. And so we have to use those different management systems and be able to buy that seed so that it's going to adapt to different climates within our region.